All right, so the first example that we're going to do is we're going to evaluate the integral from -3 to 7 of the absolute value of x minus 1 dx. So if you guys remember from when we first started working with absolute value, they were like always the weird ones, right? And what did we typically have to do with the absolute value?
Plus and minus.
Yeah, we had to rewrite it as what? A piecewise function, okay? And then we had to think of it as two separate straight lines instead of thinking it as one graph that had a V. So we're going to do that same thing again. We're going to rewrite this. So I'm going to say if our original function is absolute value of x minus 1, I can't have that. I'm going to rewrite that as a piecewise. And I have two versions of it. I have the positive version of what's inside the absolute value symbol, and then I have the negative version of what's inside the absolute value symbol. And then I have to give the restricted domain for each of those lines. Is this ringing a bell? You remember this? Okay. So we use the positive version if
it's greater than
x is greater than
3,
1. And that's because the vertex would be at 1. Okay? If x is greater than 1. And if, oh, I was going to say if again, if x is less than 1, and one of these has to have an equal to, we don't care which one. Greater than or equal to? Okay. Bryn, they didn't listen to you. Okay. It's okay. So, I answered for you, but we're okay with it. It's fine. Okay. So now what we're going to do is instead of writing this as one integral like this, which your calculator can handle this, by the way. So if this was a calculator active question, you would like not even do this in your head. You would just straight up plug it in your calculator and be fine. But when we do this by hand, we can't handle it this way because there's no special rule for absolute value. The special rule is, yeah, you got to rewrite it and do it by hand. Okay? So what we're going to do is we're going to write this as the sum of two different integrals. And we're going to use one integral for the top and one integral for the bottom of these. Okay? So from -3 to something, and then from something to 7. That's what we're going to have. Okay? So I'm going to start it off. I'm going to say from -3, and if you look at this, -3 applies to which one of these? The bottom one. Okay, so -3 to what number? Where does it break off? 1. So we're going to say from -3 to 1. I'm going to do integration for -x plus 1 dx. So instead of writing this with a negative out front, I just went ahead and distributed that negative. Okay? All right. Now, plus, what else do I have to get the original problem? One to 7. And then which piece can I use that has the part of the graph that's greater than 1? Yeah, the x plus, or the x minus 1. Okay, so now what do we do to integrate?
we use our properties.
Yeah, we use our little rules, right? So -x currently has an exponent of 1. What am I going to do? Plus 1 and divide by 2. And so that gives me 1/2 x squared. Negative, yeah, negative 1/2 x squared. Plus, and what do we do with the 1? We put an x on it. Okay? And that is being evaluated from -3 to 1. And in this situation, we do not put a plus c because we're working with definite integrals. So anytime we have definite integrals, we do not deal with the plus c. Okay. So we're going to be evaluating this, and we're going to add this to, what do we get for this one? 1/2 x squared minus 1x, evaluated from 1 to 7. All right, now the annoying part of today is that I'm going to make you do like all these evaluations by hand, because when students make mistakes, this is where they're going to make the mistakes, because they're not difficult per se, but it's a lot of fractions and things like that, and I find that students make a lot of little computation mistakes if they practice with a calculator too much. Does that make sense? So I want you to practice by hand and then verify your answer using a calculator. Okay. Now, I was not hypocritical when I did my answer key. I did the entire thing by hand and I checked with the calculator in hand. Okay. So yes, everything I'm going to ask you to do, I also did by hand. Okay. So let's go ahead and start with this part. How do we evaluate this from -3 to 1? Plug in 1, right? And then plug in -3 and you subtract those results. Okay. So I'm going to say plugging in 1, I've got -1/2 times 1 squared plus 1, and from that I'm going to subtract off -1/2 times -3 squared plus -3, and whatever that is, I'm going to get that result, and I'm going to add to it the result from this one over here by doing the exact same thing. Okay, so over here I have 1/2 times 7 squared minus 7 minus 1/2 times 1 squared minus 1. So not hard, just messy, right? Yeah. Just a lot of opportunities to make mistakes if you're doing it by hand. All right, so I'm just going to simplify each piece a little bit at a time. How are we doing with those fractions? They're kind of okay right now. They're going to get worse in a second. So this one is 1/2 minus this 3 right here, I'm going to think of as 6/2. Why is it beneficial for me to think of it that way? Yeah, common denominator, then I can actually deal with those fractions. So I'm minusing off -9 minus 6 is -15/2. Okay, so I have that, plus I'm going to think of this one as 14/2. 49 minus 14, 35. So 1/2 minus -15 would be 16/2, because minus minus makes a plus. Plus minus minus makes a plus again, 36/2. So that's 8 plus 18. Whew. Worked out nicely. Hey, Emily.
I thought Miss
Okay.
Price was the one who said, "Hey, girl."
Hey, girl. What's up? All right. So what we're going to do is we're actually going to graph this one so we can see it. And then I'm going to show you guys 2 different ways to find the answer on your calculator. All right. So in the y equals screen, we're going to graph the absolute value function x minus 1. So we're going to hit, to get to the absolute value sign, you're going to hit the math button and go over to number. And it is the first option. We're going to type in x minus 1. And for your window, you can do a normal window. You'll be able to see it.
Can you just put the equation squared but then square rooted as well?
Say it again?
Can you just put the equation as squared but then square rooted instead of doing the absolute value?
Yes. That's tricky. Yeah. But then would that show... Try it. See what it does. Did you try it? I was not anticipating that question, so my brain is a little bit slower than it should be. All right, so
I can't find that button.
to type the absolute value graph, you hit the math button, and you go over to number, and it's ABS. It's the first one for absolute value. Okay, so it should look like this. Your window can be the same as normal, and then we'll go ahead and hit the graph button. Okay, now do you guys remember how we could find the derivative at a point? But how did we get to that? We do second trace, or we do calc, and then we could go down and we could do dy dx, right? We could find the slope at a point. Now if you go one further than that, now that's saying the area underneath the curve. Oh, tricky. What? Okay, so the lower limit on this problem, now because the calculator can handle the original problem, we're just going to go back to the original and do all of that. So we're going to say -3 is my limit, +7 is my upper limit, and it's going to find that area for us. Cool, right? And you can even see the area, so you can visualize what it's talking about. So again, to do that, I did second trace. I went down to number 7. When it asked for my lower limit, I typed in -3. When it asked for my upper limit, I typed in 7. And you'll notice the answer is almost right. It's a little bit off. And that's one of the reasons that it's better for you to do these by hand necessarily than in a calculator. But if we were to try to write this down and round to 3 decimal places, we would still say 26.000, right? Because of the way that the decimals are working, so we'd still get the right answer anyway. But I've noticed that sometimes your answer is literally like 1 trillionth off, which is still pretty accurate. Okay. All right, so that's how you do it graphically. Okay. All right, go ahead and do second quit to get out of that screen. Now, there's one thing I forgot to teach you with the derivatives, just with using your calculator, and I forgot because we've done so much without our calculators. So what I might do is I might come up with just a little calculator assignment that will literally take you 10 minutes and just make you find a bunch of derivative at a point and evaluate integrals just to practice the calculator aspect of this. But if you hit the math button and scroll down, number 8 actually lets you type in what you want to find the derivative of and what you want the point to be. So let's say we want d dx. The x that I'm using is this x right here. I'm not using alpha. I'm just using that x right there. Or not alpha, but I'm not using like alpha and then choosing the x. So I'm typing this x right here. Let's say we wanted to find the slope at a point of like x squared, and we wanted to find the slope at 5. We know that the derivative of x squared is 2x. So we know the slope is going to be 2 times 5, which is 10, right? And the calculator will just spit out 10. So I showed you guys how to do that graphically, but I didn't show you how to do it this way because I forgot about it, to be honest. Okay? So I might come up with just like a little assignment for you guys to just practice that, just a short thing. But if you hit the math button and you go down one further, then you can integrate the same way, where you can just type it on your screen. So we're going to integrate this time. The lower bound is -3. The upper bound is 7, so that was, you hit the math button, number 9, math 9. And then we're going to hit alpha, not alpha, we're going to hit math, go over to number and use absolute value, x minus 1 dx. And then it gives us the same answer. Okay. So there are some questions. The nice thing about the calculator doing this for you is the calculator can solve problems that you are not mentally capable of doing by hand yet, because it's a level of calculus that is beyond high school calculus. So there's some problems where we'll look at that and be like, oh, I can't do that. And then be like, oh, this is a calculator active problem. Let me just plug it in and see what it is. Okay. All right. Does that make sense for those? Okay, so what I might do is I might try to generate a worksheet real quick and just give you something over the weekend. It will take you 10 minutes with a calculator. Sit down and just practice typing it in. Okay? All right, so we did get the right answer, which is a good sign. Okay. Any questions about the homework from last night? Did it kind of make sense what we were doing?
Yeah.
So it's exactly what we did yesterday. It's just adding another piece now where we're plugging in numbers to find the exact area. Okay? All righty.